Next is question number 76, which says that the fundamental period of the function fx equal to tan inverse tan x minus tan inverse cot x is. Now we know the formula for tan inverse x minus tan inverse y. It will be equal to tan inverse x minus y upon 1 plus xy for xy greater than minus 1. Here it can be seen that tan x into cot x, that is equal to 1, that is definitely greater than minus 1, which means that fx will be equal to tan inverse tan x minus cot x divided by 1 plus tan x into cot x, that is 1. So this is equal to tan inverse tan x minus 1 divided by tan x and whole multiplied with 1 by 2. So that is equal to tan inverse, in the denominator we will have 2 into tan x, and here we will have tan square x minus 1. So this can be written equal to tan inverse. Taking minus common, we are left with cot 2x. Now this can further be written equal to minus can be taken out. So we'll get minus of tan inverse cot 2x. That will be equal to tan of pi by 2 minus 2x. Now we know the period of tan inverse tan x, that is pi. So here we have 2x, which means that its period will be pi by 2. So correct answer will be option number 2. Let's now discuss question number 77, which says that if the equation sin inverse x is equal to 2 times tan inverse a has a real solution, then the set of exhaustive values of a is. We know the range of sin inverse x, that is sin inverse x, that is it goes from minus pi by 2 to pi by 2. So 2 into tan inverse a should also go from minus pi by 2 to pi by 2, because we want a real solution. That is tan inverse a should go from minus pi by 4 up till pi by 4. That is a should go from tan of minus pi by 4, that is minus 1 up till 1. So the set of exhaustive values of a will be minus 1 to 1. That is option number 1 is the correct answer. Next is question number 78, which says that limit n tending to infinity summation r equal to 1 to n cot inverse n square multiplied with r square plus r plus 1 plus 2n plus 1 divided by n square plus n is equal to. So we have to find limit n tending to infinity summation r equal to 1 to n cot inverse theta can be written as tan inverse 1 by theta. So we'll write it as n square plus n. Taking n common, we will write n plus 1 divided by, here we have n square r plus n square r. So that can be written as, taking n square r common, r plus 1 plus n square plus 2n plus 1. That is n plus 1 whole square. This is clear? Now we can further write it equal to limit n tending to infinity summation r equal to 1 to n tan inverse. Now dividing in the numerator and denominator by n plus 1 whole square, we will get n divided by n plus 1, and in the denominator we will have 1 plus nr divided by n plus 1 into n into r plus 1 divided by n plus 1. Now here it can be observed that we can write n upon n plus 1 as n multiplied with r plus 1 upon n plus 1 minus nr divided by n plus 1. Right? So we have got the formula tan inverse a minus b upon 1 plus ab. So this can be written equal to tan inverse a minus tan inverse b. So this will be equal to limit n tending to infinity summation r equal to 1 to n tan inverse n multiplied with r plus 1 upon n plus 1 minus tan inverse nr divided by n plus 1. Here it can be seen that r is going from 1 to n. So cancelling the terms, we will get it equal to tan inverse n into n plus 1 upon n plus 1, that is tan inverse n minus tan inverse n upon n plus 1, putting r equal to 1. So if n is tending to infinity, it will be equal to tan inverse infinity, that is pi by 2, minus this can be written as tan inverse 1 divided by 1 plus 1 by n. So n is tending to infinity, it will be tan inverse 1. So that will be pi by 4. So this is equal to pi by 4. So answer will be option number 1. Next is question number 79, which says that for the function fx equal to greatest integer of 2 divided by greatest integer of x. So we have to find which of the following is correct. Now let us break the function at x equal to minus 1, 0, 1, 2 and 3. So if we check the domain of the function, we can see that greatest integer of x, as it is in the denominator, it should not be equal to 0, which means that x should not take the values from 0 to 1. Right? Now we will find the value of fx when x belongs from minus infinity to minus 1, when x goes from minus 1 to 0, when x belongs from 1 to 2, and when x belongs from 2 to 3, and when x goes from 3 up till infinity. Now when x goes from minus infinity to minus 1, so the value of fx will be minus 1, and when x goes from minus 1 to 0, then in the denominator we will get minus 1, so we will get minus 2. When x belongs from 1 to 2, then in the denominator we will have 1, so we will get 2 here. For 2 to 3, in the denominator we will get 2, so the value will be 1. And when x goes from 3 to infinity, then the value will be equal to 0. So number of integral values of x which do not belong to the domain of fx. In the domain, the only integral value which is not here is 0. These two are incorrect. Now range of fx is minus 2, minus 1, 0, 1, 2. So option number 3 is correct. And option number 4 says that it is an even function, which is not true. So answer will be option number 3. Next is question number 80, which says that number of distinct integral values that the expression sin inverse x whole square plus cos inverse x whole square can attain is. We have already discussed this type of question, that to solve this we will convert cos inverse x into sin inverse x, or we can convert sin inverse x into cos inverse x. So we can write it equal to fx. So that is equal to sin inverse x can be written as pi by 2 minus cos inverse x whole square plus cos inverse x whole square. So this will be equal to 2 times cos inverse x whole square minus pi into cos inverse x plus pi square upon 4. We have to find its range, so let us make it perfect square. Taking 2 common, we will get cos inverse x whole square minus pi by 2 cos inverse x plus pi square by 4. So this is equal to 2 times cos inverse x minus pi by 4 whole square minus pi square upon 16 plus pi square upon 4. So this is further equal to 2 times cos inverse x minus pi by 4 whole square minus pi square by 8 plus pi square by 4. So that will be equal to plus pi square by 8. Now we have to find the range of this. We know that cos inverse x goes from 0 to pi. Hence, cos inverse x minus pi by 4 will go from minus pi by 4 up till 3 pi by 4. And if we take its square, then we can say that cos inverse x minus pi by 4 whole square, it will go from 0 up till 9 pi square by 16. So multiplying it by 2, we will get that it will go from this multiplied with 2. So adding pi square by 8, we can say fx will go from pi square by 8 up till 9 pi square by 8 plus pi square by 8, that is 10 pi square by 8. So this is 1 point something and this will be 12 point something. So the integral values that it can take are 2, 3, 4 and so on up till 12, which means that in total we have 11 integral values. So answer will be option number